Welcome to Tabo Eminent channel. Here's a compact field guide to uncovering hidden, aka blind, geothermal systems in Iceland. Places with heat but few obvious surface clues. Start with what Iceland already knows. Thanks for watching. Request you to subscribe the channel. Tap National plus Institutional Datasets. Orkustofnun, National Energy Authority, tracks geothermal utilization and power assets. ISER, Iceland GeoSurvey, provides geophysical surveys, reports, and maps, especially resistivity. These are your first stops for leads and legacy data. Iceland sits on top of one of the most geologically active regions on Earth, where the Mid-Atlantic Ridge and a powerful mantle plume meet. This restless setting fuels the country's abundant hot springs and geysers, but not all of its geothermal wealth is visible at the surface. Beneath stretches of moss-covered lava and barren highlands lie blind, geothermal systems, reservoirs of superheated water and steam hidden under thick rock layers with little or no surface expression. Uncovering these hidden sources has become a frontier in Iceland's energy story, as the nation looks to sustain and expand its renewable energy dominance. Scientists begin their search by revisiting the rich archives of the National Energy Authority and ISER, Iceland's Geothermal Survey Institute. These records hold decades of resistivity maps, temperature logs, and well data that often hint at overlooked zones of potential. Modern technology now allows them to sharpen these clues. Magnetotellurics, MT, which reads Earth's natural electromagnetic signals, has revealed a telltale pattern of geothermal systems, a conductive clay cap sealing a deeper, hotter reservoir. At Reykjanes and Krasuvik, 3D MT imaging has already highlighted likely hidden reservoirs where surface steam is minimal. The deeper story is even more dramatic. Iceland's participation in the Iceland Deep Drilling Project, IDDP, proof that wells reaching supercritical conditions, over 400 degrees Celsius and near magma contact, can unleash 10 times the energy of a conventional well. In 2009, drillers at Krafla even hit magma directly, creating the rare opportunity to study a magma hydrothermal interface. These efforts show that Iceland's hidden geothermal resources are not just small, tucked-away systems but vast, untapped reservoirs that could redefine renewable power. The approach blends geophysics, seismology, and geology with careful drilling. Scientists listen to swarms of tiny earthquakes that trace permeable fractures underground. They measure subtle gravity changes that betray buried intrusions. They even map invisible gas emissions creeping through fractures. Together, these techniques build a three-dimensional picture of where superheated fluids circulate. Slim exploratory wells then confirm temperature and permeability, setting the stage for deeper drilling. What makes these hidden systems so valuable is their potential to expand geothermal development without disturbing Iceland's most famous hot springs and geyser fields, which are vital for tourism and heritage. By targeting reservoirs concealed beneath lava fields or caldera margins, engineers can add capacity quietly and sustainably. In the future, projects like the planned Krafla magma testbed, instrumented boreholes directly into magma, promise to reveal even more about the deep plumbing of Earth's heat engine. Iceland sits on top of one of the most geologically active regions on Earth, where the Mid-Atlantic Ridge and a powerful mantle plume meet. This restless setting fuels the country's abundant hot springs and geysers, but not all of its geothermal wealth is visible at the surface. Beneath stretches of moss-covered lava and barren highlands lie blind, geothermal systems, reservoirs of superheated water and steam hidden under thick rock layers with little or no surface expression. Uncovering these hidden sources has become a frontier in Iceland's energy story, as the nation looks to sustain and expand its renewable energy dominance. Iceland's landscapes, where black lava deserts meet steaming valleys, give the impression that the island's geothermal energy is all laid out on the surface. Tourists marvel at geysers, boiling mud pots, and the famous Blue Lagoon, But much of Iceland's true geothermal treasure lies hidden below layers of rock, without dramatic surface clues. These blind systems are invisible to the naked eye, yet they hold the same, or even greater, potential for clean energy as the more obvious hot spring fields. For Iceland, a country that already powers almost 90% of its homes with geothermal heat, finding these hidden sources is not just scientific curiosity. It is a path to strengthening energy independence and pushing the boundaries of renewable power. The search for hidden heat begins with maps and instruments rather than smoke and steam. Scientists from the National Energy Authority and Iceland Geosurvey pore over decades of resistivity surveys and drilling records, looking for subtle anomalies. Where the land looks quiet, magnetotelluric imaging can reveal the fingerprint of geothermal activity, a shallow, conductive clay cap formed by hydrothermal alteration, lying over a hotter, resistive zone at depth. In places like Reykjanes and Krasuvik, these invisible patterns have pointed to reservoirs that surface explorers would never have guessed were there. But Iceland's geothermal story is not only about finding more of the same, it's about pushing deeper. The Iceland Deep Drilling Project, IDDP, has shown that supercritical wells, where water exists at extreme temperatures and pressures, can generate vastly more energy than conventional ones. At Krafla, one borehole even struck magma itself, turning a potential drilling disaster into a scientific milestone. Such encounters hint at a future where Iceland's hidden geothermal systems could provide extraordinary amounts of power by tapping heat directly from Earth's fiery heart. For explorers of this hidden energy frontier, earthquakes become guides. Small swarms of tremors often mark fractures where hot fluids flow. Gravity measurements betray underground magma bodies, while tiny gas leaks at the surface provide chemical whispers from deep reservoirs. Piece by piece, geophysicists assemble a 3D map of Iceland's underground heat engine. Only after these invisible signatures are aligned do drillers sink slim wells to test temperatures and permeability, carefully probing what lies beneath. The promise of blind geothermal systems is enormous. They allow Iceland to expand power generation without disturbing its iconic hot spring landscapes, preserving both natural beauty and tourism. Each hidden system uncovered is not just another power plant site, it is a step toward understanding the deep, dynamic processes that make Iceland both a land of fire and a leader in renewable energy.